So we are now moving to the next and last session. Yet once again, sorry for the delay. You are still connected to the IRT Nanoelec workshop on bridging the gap between technologies and architecture. And the next session deals with cybersecurity. The first presentation will be given by Jacques Fournier, who is the head of a research lab at CEA Leti in the system division, working on cybersecurity at the components to embedded system level.
Thank you, Ig. Good morning, good afternoon, everybody online. I have the pleasure and honor of introducing this session on cybersecurity. I will try to keep it short just to catch up on some time, and I also unfortunately have some operational constraints due to the whole havoc with the coronavirus and things to be reorganized at the team level. So the objective of this presentation is to give you an overall idea of the whole complex issues linked to the cybersecurity of industrial IoT, and hopefully settle the ground for the other two presentations from Schneider Electric and STMicroelectronics. So when we're talking about industrial IoT and cybersecurity, I'm just trying to make the... Ah, pardon. Okay, thank you. So the complexity with this whole story is that we have smart industries, and with the industrial control systems and all the legacy systems, on which there is a clear advantage of adding IoT applications and devices to enhance productivity, to enhance maintenance and monitoring, and etc. But one of the main problems that we have to deal with is that we have this entire industrial control system legacy, on which we are adding IT devices. And in terms of functionality, integration, and final objectives, there are many, usually many things which are we don't work in the same direction. And there is also a lack of understanding between those two worlds, which have been evolving and moving forward on two separate tracks, and on which we are now asking them to reunite and work together. And of course, there are many buzzwords, there are many issues to cover. The issue of cybersecurity, one of the main challenges linked to the smart manufacturing, smart industry, industrial IoT, industry 4.0, whichever word you want to use. And cyber attacks on such infrastructures today is not only a social and media phenomenon, but are also a big business in terms of revenues which hackers are trying to derive from this. There are also major security issues from national point of view. There are many business issues. There are companies which are victim of cyber attacks and which end up filing for bankruptcy due to that. We have seen stories last week. So there are all those commercial, social, and technical aspects linked to cyber attacks, especially on industrial systems. And one example of kind of devices and platforms which have been enhancing the whole phenomenon, and is, for example, most of you must probably know the Shodan website, on which you can have an overview of all the devices which can be which are connected or which can be accessed through the internet. And derived from this Shodan, you have the Shine project Shine, which is a project which demonstrates how by just having this mapping provided by Shudan, you can derive information from industrial systems. And one another declination of this is the Red Tracks projects, where actually attacks have been demonstrated on such infrastructures. So this is one of the typical, let's say, examples that can be cited of open doors on the cybersecurity of industrial systems. So, why is it so complicated when it comes to securing IoT infrastructures for industrial systems? One first issue, which I already mentioned, is this the complexity due to the fact that we have two worlds which are converging, trying to converge towards one same goal, toward the IT world, the OT world, and you have to have these those experts from the two fields who would work together, at least start to understand each other's language, start to understand each other's objectives, and try to work together, which is something which hasn't been solved yet, as far as I know. The other main challenge and problem with such applications from a cybersecurity point of view is that in terms of supply chain, in terms of stakeholders, in terms of device providers, solution providers, it's a whole world out there, and we have to try to have a scheme which takes into consideration the fact that we have several sources of equipment, devices, and solutions providers. We have this issue where we have this one conflicting issue of IT versus OT approaches is that until now, from an IT point of view, when you had a security issue, one typical way of dealing with the security issue is to shut down the system, try to see what's happening, sanitize the system, and then reboot it again. In many OT infrastructures, or in many industrial systems, or many critical infrastructures, we can't afford this. We have to maintain some the ability of service. There's a resilience issues, and for this, the security, the cybersecurity which is deployed on such infrastructures, has to be rethought and reworked again. And of course, in terms when we're talking about industrial IoT, we're talking about business, we're talking about how do we evaluate and try to have a return and evaluate the return on this investment, which we can get from implementing a particular security mechanism, because usually implementing security mechanisms has a cost, does take time, and we have to justify for this additional cost. And there is a whole discussions, issues, and research projects and how to calculate a return on the investments for security. And another aspect which is emerging right now is how do we set up and develop policies from an industrial point of view when there are cyber attacks. Just like there are the development of policies when we have cyber attacks from a national point of view. Today, for example, we have different countries who have engaged into cyber retaliation, or who are talking about cyber wars, because there are policies which have been developed around that. From an industrial point of view, there is also a whole field which is emerging today as to how to, from an industrial point of view, manufacturing point of view, how do we handle data information about emerging cyber attacks? How do we handle when we are victim of a cyber attack? And when do we decide to stop a manufacturing plant and secure it against a potential cyber attack versus the cost which it might incur to take such decisions. So when we take a very global and high-level representation of an industrial control system with three main levels of a physical level, of a control command level, and supervision level. There are many entry points in terms of cyber attacks. There have already been many studies about how to detect, monitor, and secure infrastructures from a network point of view. But what we are seeing more and more today is the active role which the device itself can have in terms of level of cybersecurity of the entire system, and in terms of how the device's vulnerability can itself be a major cybersecurity issue. So the device, the embedded system, is what we are currently working on in Nanoelec. That is in the sense that those devices are not only the objects which will be hosting, running, and delivering part of the cybersecurity solution for industrial control systems, but could also be entry points to carry out attacks. So when we take this the cybersecurity link to an object which is integrated into an industrial IoT system, there are four main aspects which need to be covered, and which I will introduce very rapidly here, and some of which will be discussed into more details by the following presentations. The first aspect which needs to be taken into consideration is the design phase of a device. So the key word which is mainly which we hear most of the time those days is the secure by design. That is, we must integrate the security aspects right from the design at the design time of the device. It's easy to be said. It's another issue when we try to implement and deploy it. The first thing is there are two main approaches. The first approach is to say, hey, let's see what there is today on the shelves, and how we deploy the best secure solutions based on what's already on the shelf. And the second approach, which is more long-term vision, is how do we redesign things to be so as to be secure right from scratch. For the first approach, the difficulty is that you mustn't be phobic to all the key buzzwords of trust something. Trusted platform module, trusted execution environment, trust zone, trust this, trust that. And there are loads of keywords which have a significant technical meaning. But you have to get into it. There's a whole process of learning what's behind, and understanding what's behind, understanding what you can do in terms of security with all those concepts and objects, and what you cannot do, what are their limits, and how to best take benefits of them. And of course, this is one of the aspects which we work on in Nanoelec, which is to say how we can build systems, secure systems by design, based on those off-the-shelf technologies. And we have with our industrial partners of Nanoelec reference designs to demonstrate this. And in the long-term vision of things, there's the whole notion of, once we have those concepts, those reference concepts of how to deploy security by design on those platforms, how do we generalize those concepts on other platforms, on future platforms, and how do we define and specify future platforms so as to be able to better integrate those security concepts. The second aspect is to say that once you've designed things, you've got to find a way to have confidence into what you have in your hands and what you're deploying. And this confidence, you can either trust the your device, the device manufacturer or provider, or say, hey, I better have try to see with a third party, and to would do tests to verify the conformity of what there is in that product versus what it's supposed to do in terms of security. So this is what I mean by certification, and it relates to the whole aspect of how do I verify the security features which are supposed to be in my product, and make sure that the way I'm deploying it in the system is relevant, corresponds to what is recommended by the device provider and by the corresponding certification label. So in terms of certification, there are lots of discussions actually at the national, international levels. A couple of keywords and entry points which I can provide is at the French level. The French ANSSI has been setting up and promoting what we call the Certification de Premier Niveau, CSPN, and which provides a certification scheme environment which can be deployed for IoT for IoT devices for industrial systems. There are also other schemes like the IEC 62443, which is an international standard for security conformance for such devices. But the latest evolution in this field was the adoption in May 2019 of the EU Cybersecurity Act, which defines a scope for the certification of IoT devices in general, with a definition of 3 levels: basic, substantial, and high level. In a nutshell, basic is self-declaration of what you have implemented, with eventually conformance and testing reports provided to the certification body. Substantial, you provide your device to a testing laboratory, third-party testing laboratory, who will run the test and validate the conformance of what you have said with respect to your specifications. And high is, for those who know, who are from the field, is equivalent to what is done today by ITSF laboratories for common criteria certifications. The third aspect is, once I have designed the thing, I have certified it so I can deploy it. And the whole deployment of the devices is an entire aspect in itself when you have to consider cybersecurity. It not only involves how you install your device, but once you install it, how do you initialize the crypto keys or the sensitive data, which will allow your device to communicate and interact securely with the rest of the system. How do you authenticate your device? How do you maintain your device in terms of, especially if for industrial systems, usually you would deploy devices for a long period of time, where you won't be changing your objects or devices every 2 years. We're more on towards decade level in terms of time frame. So you have to put into place maintenance update mechanisms. And today there is no specific standard with respect to that. There are discussions and proposals which are being put forward, but given the heterogeneity of the devices involved, their nature, the complex and very diverse supply chains, having a global and structured approach in terms of maintenance deployment is very complex today. There are specific solutions which are deployed per product, per device, per manufacturer, but it is still something which it is still a major challenge, I would say, when talking about cybersecurity of industrial systems. And the fourth aspect is, once you deploy it, how do you manage it? And how do you manage it in the long term? I already mentioned the fact of the idea of having mechanisms to update it in real during the lifetime of the product. But there are also emerging concerns about how do you make sure your device is secure, your device and solution run by your device is secure on the long term. One funny thing which some people say is it has to be future-proof. Future-proof towards tomorrow's attacks, again, tomorrow's cybersecurity issues. One thing which is clearly emerging today is the threat which might pose the emergence of quantum computers against current cryptographic algorithms. So there's this whole discussion about how do we standardize about the standardization of post-quantum quantum resistant schemes in terms for cryptography. I mentioned about secure updates. There is growing concern, issues, and studies from an academic and research point of view on the convergence between safety and security, which I already mentioned, and in terms of resilience. And to do this, you have to work on the theoretical and research side of things, but you've got also to have a proper testing environment to run the test and make sure that the solutions and devices you're deploying can actually work in real life scenarios. So in a nutshell, those are the main, in my opinion, four main issues which need to be addressed from a cybersecurity point of view. And Nanoelec has been so far, with the help of all the academic and industrial partners in Nanoelec, very active in all four fields. From a design point of view, as I mentioned, working on the implementation of reference designs for devices, secure devices for such systems. In terms of certification, here at the Leti specifically, there is an accredited ITSEF evaluation center for testing high levels of security. And based on the expertise of this team, the whole Nanoelec benefits from their expertise to address the issues linked to certification. We are currently working with industrial partners in trying to test and develop user-friendly security and deployment schemes for their products. And in terms of management, in a more long-term vision, we are working on things like new cryptographic schemes resistant to quantum computers, and more today. And this will be one of the major focuses for the future roadmap. Is to have securely implement and embed artificial intelligence into those devices. And of course, all this is possible thanks to the whole testing and demonstration infrastructure, which is available here at Nanoelec specifically for industrial systems, but more also in general for testing integrated circuits and communicating devices. Thank you for your attention.